Good afternoon, New York, and the rest of our listeners around the globe. My name is June Stoyer, and I'm the host of the Organic View radio show. Our podcast is available on iTunes, Zune, and you can also visit our website at www.theorganicview.com. If you have any questions for our guests, there are many ways you can contact the show. You can post a question on our wall on Facebook, Skype us, send us a tweet on Twitter to @TheOrganicView, or you can contact me directly at June Stoyer. If you'd like to be on the show or would like to find out about sponsorship opportunities, please contact us at questions@theorganicview.com.
Today's show is brought to you by liquidweb.com, the most reliable hosting provider with 24/7 heroic support. Listeners of today's show will receive $100 credit towards storm servers, which includes virtual private servers and dedicated hosting. Or you can try LiquidWeb's shared hosting for free for 1 month by using the coupon code ORGVIEW. That's ORGVIEW. Please visit liquidweb.com and make sure that you tell them that you found out about them on the show. As we continue our special series called the Neonicotinoid View, which was created to explore the impact of systemic pesticides, my special guest co-host Tom Theobald and I will talk to Dr. Alex Liu, Associate Professor of Environmental Exposure Biology at Harvard, about his latest research on honeybees and neonicotinoids titled Sublethal Exposure to Neonicotinoids Impaired Honeybees Winterization Before Proceeding to Colony Collapse Disorder. So I would first like to welcome to the show my special guest co-host, Mr. Tom Theobald. Good afternoon, Tom.
Hello, June, from beautiful sunny Colorado.
Hello, Tom. And our special guest today, Dr. Alex Liu. Good afternoon, sir, and welcome to the show.
Thank you for having me here, June, and hello, Tom.
Hello, Dr. Liu.
Dr. Liu, could you please share with our listeners a little bit about yourself and explain the objective of this research?
The purpose of research that we just published 2 weeks ago was to replicate the study that we did 2 years ago, looking at the association of neonicotinoid to this mysterious disease called honeybee colony collapse disorder. In our previous study, we used imidacloprid, which is the most commonly used insecticide in the whole world. But this year, in this current study, we added another very commonly used neonicotinoid called clothianidin. We want to see whether we can replicate the symptoms of honeybee colony collapse disorder, not just with imidacloprid, but with clothianidin.
Thank you. I'd like to first begin by discussing the statements made by Bayer Cropscience, which can be found at bayercropscience.us. The first statement that was made was, feeding honeybees levels of neonicotinoids greater than 10 times what they would normally encounter is more than unrealistic. It's deceptive and represents a disservice to genuine scientific investigation related to honeybee health. Dr. Liu, what is your response to Bayer's statement?
In our current study, we used the dosage of 0.7 nanogram per bee per day. So how big is 0.7 nanogram? Well, just give your audience a sense of a weight. If you weigh a grain of salt, the salt that we commonly use in cooking and so on, a grain of salt weighed about 64,800 nanograms. And we use 0.7 nanograms. So that's very, very small amount, which you couldn't even use a balance to weigh this amount of neonicotinoid out. The question that I have for Bayer is, they never publish what is so-called environmentally relevant neonicotinoid concentration that bee could encounter. So in this case, 10 times higher in their statement is relatively modest. They can say the Harvard study dose 100 times higher than so-called environmental relevant concentration. But in realistic, there is no such thing about environmental relevant concentration. It depends upon where you sample. It depends upon when you sample. So it has to be a wide range of concentration that bee could encounter in the environment. So I think that statement itself is deceptive, not the scientific finding.
Dr. Liu, this sort of leads into the question that I had, and that was how you selected the dosage that you did and how that relates to what the bees may be exposed to in the field.
Good question.
Do we have any data as to field level exposures?
Good question. So in 2009, when we first designed this study, I was looking for something called tolerance. Tolerance for neonicotinoid in various samples. There's only one, which is imidacloprid in honey, which is 500 ppb. That's a tolerance for imidacloprid in honey. So we designed a study that the highest concentration that we challenge the bee will be less than this 500 ppb level, which is 400 in our study published in 2010. Just keep in mind that 400 ppb is a concentration unit. It's not dosage. What is the concentration? Meaning that how much imidacloprid that we dissolve in the sugar water that we feed to the whole colony, not just one bee. So if you convert those from the how much imidacloprid in sugar water to how many days that we left the sugar water in the hive and how many bees that in the hive that all has a shared opportunity to come to the sugar water and take a little bit of it, it ended up being 2.8 nanogram per bee per day. That's the highest concentration that we give it to the bees. In terms of whether bee has the opportunity to be exposed to 2.8 nanogram of imidacloprid in the environment, we need those data, but there's no such data available in the literature. So how we convert those concentration dose, we basically divide it by how many bees in the hive that come to the sugar water every day. It turned out that 400 ppb of imidacloprid in sugar water is equal to 2.8 nanogram per bee per day, assuming a bee weight about 0.2 gram. Okay, so we're talking about somewhere around 15 microgram per kilogram of the body weight of bee per day. That number is very, very small.
Thank you.
The next statement that is on Bayer's website is, quote, given the artificially high levels tested over 13 consecutive weeks, the colony failure rates observed are completely expected.
Well, I'd like to ask Tom this question because Tom is a beekeeper. So, Tom, could you tell the audience how many weeks that your bee can go out to forage in the environment per year?
Well, the bees are active even in the winter during mild periods, but the foraging begins with the earliest flowering trees, and here in our region that would be toward the end of February.
Okay.
Mostly tree pollen.
Right.
Things begin to pick up in March, and the real heavy foraging begins with the dandelion bloom about the third week in April, and then continues into September and early October. So I don't know what that is in days or months, but that's the period, late February to early October.
So in other words, the beehive set up in the state of Colorado they can go out to forage in somewhere around 35 to 40 weeks. From late February to early October.
Yes.
Right? So it's 40 weeks. We challenge this low level of imidacloprid or chlorothalidin for 13 weeks. And I don't think that is worthwhile for criticism from the Bayer crowd. 13 weeks versus 40 weeks.
I agree.
Right.
They're not being exposed to neonicotinoid contaminated plants for that entire period, but more and more they are because...
But do you know?
These are, well, I suspect, and there are some studies...
We actually just published a paper. We just published papers being peer-reviewed right now that show the pollen from dandelion contain very high level of imidacloprid.
I think the environmental poisoning has been massive, so there aren't too many flowering plants anymore that aren't drawing up these systemic pesticides.
Right. So I think the criticism of 13 weeks is not founded. Because if you know how bee or when bee will go out to forage, this 13 weeks represent 1/3 of the length of a time per year that bee can go out and find something that they can take home with.
And if Dr. Tenekes of Holland is correct, he believes that the effect on the synapses is cumulative and irreversible, which means that there is no safe dose. So if they're exposed to very low levels over the course of the season, that will have the same effect.
Exactly. And also you have to understand that if a bee take back some pollen that is contaminated with imidacloprid or clothianidin or other neonicotinoid. Those pollens are fed to the pupae. You're talking about feeding the baby with those toxic chemicals, and the consequence will be even more detrimental than the adult bee exposed to neonicotinoid.
Well, it's interesting that you say that. What began my journey on these systemics was in the fall of 2007 when I physically inspected each of my colonies after the harvest to see what the mite levels were. Typically, a beekeeper would not do that. But what I discovered was a break in the fall brood cycle that began about the third week in September. That's the period when the winter bees are being produced. And as a consequence of that, there are few, if any, winter bees. I postulated that the source of that break in the brood cycle was contaminated corn pollen that was gathered in August and not fed to the larvae until September when the floral spectrum began to shrink.
Right.
I wonder if you observed that break in the fall brood cycle, because that certainly has an effect on the overwintering survival.
Our studies, we set up those hives in a relatively so-called clean environment. We purposely do that so we don't want to have some influence from outside. And we only want to study the imidacloprid that we put it in the sugar water. But Tom, you're right. If your bee has access to neonicotinoid in pollens where either coming from the corn or from the tree, you will see the problem when the season turns to fall, because those pupae that come out, they're all fed with the pollen that contaminated with neonicotinoid. And that is something that need to be discussed by USDA. However, they haven't talked about this yet. They basically shut this neonicotinoid off from their radar screen because they don't even want to bother. But this is very critical because, again, finding pollen that is contaminated with neonicotinoid would be much more detrimental than adult bee exposed to neonicotinoid, just because what Tom has mentioned.
Thank you. And now the last statement that appears on Bayer Cropscience's site, their conclusion, which is, quote, unfortunately, this latest study conducted by Dr. Liu repeats the fundamental flaws seen in his previous research and provides no meaningful information regarding honeybee risk assessment, end quote.
Well, I don't know. I really don't know how to address this criticism. I think we have replicated ourselves twice, and we are the only study that can replicate so-called CCD using just neonicotinoid as a study variable. So I don't know. I really don't know how to answer this question. I think it's up to the reader to decide it, whether the study that we publish is credible or not.
Well, it isn't really a question because they haven't said what they challenge. I mean, it's just a vague assertion of something. I don't know.
Well, we published the first paper in 2010. If Bayer Crop really has their doubt in the study that we published, they could replicate the same study and come up with a different result. They haven't. Again, this is not a very expensive study. They could do it very easily because, we're talking about a very small amount of money versus how much they make from selling those neonicotinoids. So not willing to or wanting to replicate our study kind of tells you that they probably know the result, and that's why they don't want to do it.
Thank you. Dr. Liu, thank you so much for coming on the show today. I do appreciate all of your time, and I wish you all the best, especially with your next paper.
Thank you very much.
Dr. Liu, thank you for talking with us today, and I know that you've come under some pressure. I hope you will continue with what you're doing.
Well, I have to say that a lot of conversation and discussion are very positive, lead to a lot of idea for the future study. I appreciate those positive and constructive comments. And good luck to you, Tom, to your bee.
Thank you.
And folks, thank you so much for tuning in. This has been June Stoyer with your Organic View radio show. Have a great afternoon, everyone.